Hello friends, this is Matt Domain and today we will discuss about composition of functions. Everything I have discussed earlier in my video, but those videos are actually a bit long and means not that interesting. So as you know, I will explain everything in terms of diagram. So in the previous video we have learned about function from A to B. Now, as we have numbers 1 plus 2 equal to 3, so this plus is our operation. Then 2 into 4 is equal to 8, then this multiplication is our operation. In the same way, the function has its own operation. So, that operation is called function composition. Function composition. Now the very basic question is every function can be composed? Means can I make composition of any two function? Okay, so this is a question and the clear answer is no. So there are certain the function should satisfy some certain property. For those functions I can compose them. Okay, so let's understand what are those. So suppose I have two functions, f from A to B and g from B to C. See, you can observe that while taking the domain codomain, I have chosen the codomain of f and the domain of g are same. Okay, we don't know about the range, but at least I can say that the codomain of f and domain of g both are same. Now we can, for such function we can compose. Now this is defined as just for writing f of x and this is g of x. Now the composition of function can be written as, these two functions can be written as g of f from A to C. Now how it came into existence and how to define that GOF. What is this GOF basically? Okay, GOF is just like F and G. It's a symbol. O is here for composition. So O is the like plus into divide. This O is a composition of two functions f and g, but I have written GOF, not FOG. Okay, I'm giving you some spoiler that in this two functions FOG is undefined. You cannot define FOG. So how this GOF is defined in this case and why A is written here and C is written here? So what is the scheme of doing composition? Okay, so the scheme of doing composition is like this. Let me draw some diagrams. So this is suppose your A, then this is suppose this is B, and this is your C. Now from A to B I have F, from B to C I have G, but GOF is a function from A to C. Now how this function is defined? It means, what is a function? In my last video I have told you connecting every point of A to a point of its codomain. So for GOF, this is GOF, let me write it, not GOF. So this is GOF So for GOF, I have to connect every point of A to a point of C using G. Okay, now how to do that part? Suppose this is a point X. Now under this map, X is connected to a point, actually to a unique point of B. So this is unique. Now this point, this particular point, I can write it as f of x. Okay, now again G is a function on B, so it will take that particular fx to a unique point. Remember, this fx is unique for this x. Now again for this fx, I'll get some point y in this C, which is also unique. So how do I get this point? G of fx. It means this x is connected to a point of C through the definition G of fx. Now I can define, let me take some new page. Now I can define the function GOF from A to C. What is the definition of GOF? This is of x is nothing but G of fx. Okay, now this is a function. This is called composition of two functions. Just go to the previous diagram. Here every point of A will map to some point of B. It means, and those points will again map to some point of C. It means every point of A is connected to C. Okay, first condition is satisfied. Again, the uniqueness, that one point of the domain will map to exactly one point of the codomain. So this x maps to f of x uniquely, and f of x maps to g of f of x uniquely. So means x maps to a point of C uniquely. So this satisfies the definition of a function. So this is how composition is made. Now for FOG, if you ask me what is FOG, then FOG will not form here. FOG will not form, because for that purpose I should define the function as f of g of x. Now the thing is that, what is g of x? G of x is this one. G of x lies here. Okay, g of x lies here, and there is no relation between C and A. So we stuck at that point, that no rule is there to take that g of x to a point in A. Means this reverse is not possible, because f is a function from A to B. So this is the reason this FOG is not possible in this case. Okay, if you want more properties on function composition, please write it in the comment section. Okay, bye.